Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover how to find the distance from a point to a plane using really algebraic techniques as opposed to just the projection techniques that you find in a Calc 3 class. All right, let's get into it. So, in order to do this, I need to really think about it geometrically. I'm trying to find the distance from a point, say 1, comma 1, comma 3, to some plane that lives, let's say below it, for lack of well, it really doesn't matter. So, when we look at this geometrically, what I'm trying to do is I'm trying to find the line through the point perpendicular to the plane. So, graphically, it'd have to look something like this. I'm trying to find, this piece here. So it has to be perpendicular to the plane through that point. So in order to find this, I know that R of t is going to have some, one solution point, which is going to be this 1, comma 1, comma 3, plus now it has to be perpendicular to the plane, really going to be parallel to the green line. And the plane is going to be, 3, 2, 6, which is its normal, which means that's going to be, the parallel to this particular line. So this is going to go 3, 2, 6. All right, now when I parameterize this, writing as x equals y equals z equals, so x is going to be 1 plus 3t. Y is going to be equal to 1 plus 2t. And finally, z is going to be equal to 3 plus 6t. So that is the parameterization of this green line. Now, I really need to find this point right here because my goal is to find the distance between these 2 points, to find that distance there. So I need to find this intersection point between, this line and this plane. And the way we do that is I'm going to write the plane, which is this 3x plus 2y plus 6z is equal to 6. And I need the intersection between, this plane and this line. So I'm going to plug in, the line into the plane. So distributing, I have 3 plus 9t plus 2 plus 4t plus 18 plus 36t is equal to 6. Collecting all my t, so 49t, and then my constants is equal to 6. So what this is going to give me is t is equal to negative 17 over 49. Now remember, that is not the intersection point. That's just the t value where the intersection happens. So if I plug t into this line or t into the parameterization, I'm going to get that point right there. So that means, this x, this y, this z, x is going to be equal to 1 plus 3 times, that t value. Y is going to be 1 plus 2 times that t value. And then z is going to be similar, 3 plus 6 times that, that t value. That t value being minus 17 over 49 in each one of these t locations. All right, so the point x comma y comma z is going to be negative 2 over 49. This is going to be equal to 15 over 49. And then similar, z is going to be equal to 45 over 49. Now, that gives us, this point right here. So this point here is going to give us that minus 2 over 49, 15 over 49, and finally 45 over 49. So now let's go ahead and find this distance here. Call this distance d. Now we can do this as the magnitude of the vector that goes from each point, or using the distance formula, it's equivalent. So this is going to be the square root of. I have to subtract the x components, and then subtract the y components, then subtract the z components. So remember that the x is going to be 1, 1, 3, so 1, 1, 3, and then I have to subtract off, the point I just found. So minus 2 over 49, 15 over 49, and then 45 all over 49. So simplifying this, we're going to get 51 over 49 squared plus 34 over 49 squared plus 102 all over 49 squared. So simplifying this, put them together, I get 14,161 all over 2,401. They're both divisible by 69, so I got a 289 all over 49. And actually, these things were perfect squares. I should have just did that in the beginning. So this was 17 all over 7. So this happens to be that distance. So if you like the content, please subscribe. Thanks for watching.